Has anyone besides Adam used Atlas? Yeah.
I've used it minimally, Luke, but I do know what's in it. It's kind of some cool stuff, but I don't know all the ins and outs.
Were you looking for the LiDAR? I know that's what most people come here for. Yeah, and it's kind of surprised that there isn't an official, Louisiana government website that provides, especially this data set, because it seems to be pretty popular. So as far as I know, Atlas might be the only website that's providing this LiDAR data set. I mean, it's getting pretty old now. Might be considered a historical data set at this point. But it might be available on the Earth Explorer website. I know that they have some elevation data, but I'm not sure if it's from the Atlas data set or if it's just from some of the satellite-based LiDAR measurements. So Atlas, aside from being a website, it's more of an ongoing project to preserve some of these data sets and to keep them freely available for download. And it's over 20 years old now. Started with the person who was basically my predecessor before I came to LSU in 2012. He had started it in 1999, even before all of the LiDAR data was available, just to be a central place to get some of Louisiana's, what was available back then as far as Louisiana's GIS data, including some imagery and as well as the topographic maps that were being produced by USGS, and then whatever vector data, like shapefiles, was available back then. And so it basically stayed in that its same form for about, for the next 15 or so years until I updated it in 2016. And the main way of delivering data from the original Atlas website was to offer zip files for downloads, which is still a big part of how Atlas operates today. And it's necessary to be like that because some people, they do want to actually download the source data, open it up in their own GIS applications and work on it, not just see a preview or a base map or something like that that's available as a web map online. A lot of people still need to actually obtain that data for themselves on their own computer, share it around their offices or whatever. But one problem though without having any base maps or an online version of that data that people are downloading is that there wasn't really any way to preview what you were downloading on Atlas. It was also plugin dependent, and so if you used Atlas prior to 2016, you would have to install Java. And so over the years, since I got involved in Atlas and started taking over maintaining it in 2012, it got harder and harder to use the site because plugins like Java were becoming less and less acceptable, and compatibility and stuff related to security with browsers. Basically, browsers started making it more and more difficult to use a plugin like Java on the site, and you had to, eventually it got to the point where you were having to change your browser security settings to allow all of this exceptions for Atlas and things like that for it to run these Java-based plugins. So another issue with Atlas is basically that it was built in Visual Basic or VB Script from scratch. And like I said, my predecessor who started it all, he retired. And so he was the one who made it. He was really the only person who understood it, and to make any kind of changes to it, it involved a lot of reverse engineering. But as I'll admit, it kind of became the thing that I set out to destroy. It still is like that, to where I started out with trying to use some open standards and open source stuff, and but eventually built something that in a large part was from scratch, and I'm the only one who knows how it works. And so now I have to go back and kind of fight with myself from the past to figure that stuff out and move it to something that is more easily maintained by other people, and not just an application that was developed from scratch in-house. So the 2016 update was a visual update, and so making it look more like a modern website, but also function more like a modern website with in terms of how you could search for things and how it's all laid out. But also on the back end, there was some significant updates in how data was going to be delivered. And so not just offering the zip files anymore, but also offering the ability to preview some of this imagery, and then also make it available as web services. And web services, and another term, API, are terms that probably seeing more and more often if you're going out and searching for GIS data online, or really any kind of data online. And so web services are basically a way to offer your data to users with for programmatic access. So not just physically getting on your website or manually getting on your website and clicking a link to download individual zip files, but offering an interface for programs to interact with. So it's a little bit different from a website in that you can have either applications that you developed yourself automatically pull data from your data sources, or it could be just a program like QGIS, where instead of downloading files to your computer and then opening them in QGIS, you can just point QGIS to open up a web service URL and display the data that it gets from that web service. So I know that's something that has been covered in previous talks here in this group, but that's what it is. It's a web service, and it's just a different way of making your data available, and more with the intent of making your data accessible to applications instead of just people getting it manually. Okay, so if I just go back to this slide. So there's 3 ways of getting data from Atlas. I can jump over to the actual site. I put it in screenshots in PowerPoint in case there was some kind of catastrophic failure, but we should be able to view it. So looking at the LiDAR dataset page, it's one difference, I guess, or one update is trying to consolidate some of the information about each data set and put it in more or less a standard format in a web page. Because I would get so many emails asking for basic information about these data sets, including the LiDAR, like what was the resolution and the coordinate reference system and stuff. So it's clear that that information just wasn't easy enough for people to get to. So it really needed to be standardized and put into easy to read and easy to access web pages. And so from the dataset pages, I have a link to the downloader, or what was in the past Atlas website was referred to as a downloader. So basically just a separate web page or application that lets you pan around a map and click on it to download individual tiles for imagery data. And then also I started up an FTP server so that people could download it in bulk. And I'll go into each one of these in a little bit more detail. And then the link to the web services that I was just mentioning. So if I go to the map, so this entire LiDAR data set, I gave it the name LiDAR 2000, but it was actually, the missions were flown like between 2000 or maybe just before 2000 through 2006. So it wasn't a data set that it all started out as a coherent data set. It was kind of funded over time funded by different sources and different missions flown. And then after more than half a decade, kind of put together as a single data set and called the Louisiana statewide LiDAR data set. But it's not like it was all flown in one winter or anything. It was quite a long period of time over which the data were collected. So all tiles put together, it looks like this. And with this downloader, you just zoom in to the individual grid units there. And so each rectangle is supposed to represent the footprint of an individual tile of the LiDAR data that more or less corresponds to these grid units developed by USGS as a standard way to break up the country into these uniform units. Right, and so these are 1/4 of a quadrangle. So again, it's just a unit that the USGS used as a standard measurement, and it's like what their old topo maps were based on, these different units at different scales. And so each one of the quarter quads has a unique name given to it, and then an ID. Makes it a little bit easier to reference. And so as far as downloading it, you just click on it, and then it gives you the files that are associated with it. So they should each have a DEM, digital elevation model file, that you can download, right? And so you get these in zip format, and then you can open them up in your own GIS applications on your computer. So the other way to access these data sets would be to go onto the FTP site. And the advantage of doing it this way is that you can get an FTP application. So instead of accessing it from your browser to download it, you can use an FTP client that will let you browse through this as if it were a folder on your computer, more or less. So if you wanted to download the entire data set, you'd be able to do that without having to click on thousands of individual tiles. You could just select them all and then download them to your computer. And then the web services that I mentioned, if you've browsed for GIS data online before, you might have come across a page that looks something like this. This very plain text-only type of page that is associated with an ArcGIS server product, or ArcGIS Online, which is running ArcGIS server. Okay, and so that's what the web service basically is. If you're going to look for some kind of visualization of what a web service is, it's a page like this. It gives some basic information about the layer. And this URL is what you would copy to and then paste into your own GIS application. Something like QGIS, or like I said, something that you developed yourself, like another web page. Screenshot there of an FTP client if you've never used one before. It's just kind of like a different way to view the files that are available on a web server or an FTP server. Right, and then an old screenshot of QGIS, bringing in one of the web services for some coastal imagery. Of course, the advantage there is that if you wanted to just view a basic map like this, okay, so the one that covers that entire 2008 imagery that's available on Atlas, you would have to download all of those thousands of individual image tiles and then mosaic them all together yourself to finally get a product that looks something like this. Whereas with a web service, you just paste in the URL and then the entire data set is visible to you. So that's what the changes in 2016 Atlas look like from the user perspective, but I'll talk something about what goes on behind the scenes and some of the software that I use, or some of the software that I plan to use in the future with Atlas. And I think it's not just a look behind the scenes of Atlas, but maybe some insight into what other GIS portal type websites are using. If you've looked for GIS data online, you've probably noticed a pattern of sites using or looking kind of similar maybe, because they use certain types of software that are pretty common, and Atlas uses some of that same software. So it might be a bit of an insight into what happens or how GIS portal sites are run more generally. So as far as what needed to happen behind the scenes to get these three methods for downloading data all working together without having to duplicate the files, if some of these data sets might be over a terabyte or something, didn't really want to duplicate that and have one data set available for web download, one for FTP, and one for web services. So it kind of had to wrangle the software a little bit and get a configuration to where it was all kind of feeding off of the same data set. Right, so if you imagine downloading a SID file, a particular image from the web downloader, then that file needed to be the same file that you're going to download if you are downloading it from the FTP site. And then if you're viewing the base map, it needs to be pulling its preview or the actual image file that you see in the base map from that same SID file that's available through the other two methods. So basically, to make it a little bit more tangible, if you have a file sitting in a folder, you want all three of those interfaces, you could say, to be reading the file from that same folder. And so if I can just pull it up here, so this is a network folder that points to the storage device on that some of this imagery is stored on. And so if I look inside this distribution folder and look at the 2010 GOSEP imagery, you can see it was provided to me broken up by parish. So if I go down all the way into one of the parish folders, I finally get to the point where I see actual data, okay, the actual image files. So if I go and look at that online, then I click on one of the tiles and then download a SID. So that SID file that I'm downloading, or any other user would be downloading, would be coming from this same folder, the same data source. And I can show some of these servers too. So basically we have a storage server where all of the files are stored. And then we have a GIS server that is actually going to run the web services. And so when you see in a web service a base map that shows the imagery, it's going, that GIS server is going to be reading the data that's stored on the data server. So in the top left there, if I go into that server, you can see that it's just running Windows. So again, to try to make it a little bit more tangible and not really as abstract a thing as to just call it a server, it's just essentially a computer running Windows, and has a lot of drives, or we call them volumes, connected to it. And these aren't just hard drives that are inside of a computer. It's a little bit more complicated than that. It's an external storage device that you can basically, it has dozens of disks in it, and you can kind of carve up those disks into different volumes to kind of separate your storage into different categories and things like that. And so your higher demand stuff can be assigned certain disks or more disks. That would be faster and things like that. So you can see the imagery is what takes up the most storage. So there's a few volumes dedicated to imagery. There's one of the disks, it looks like it's filling up because it has a mere 923 gigabytes left. So the storage device it has, like I said, dozens of disks in it, and so the total disk storage is on the order of dozens of terabytes. It is theoretically more than 200 terabytes worth of disks, but the way you configure them with some redundancy, it doesn't get, the actual storage space isn't anywhere near that. But with some of the raw imagery that people have given me, that's not available on Atlas, but if somebody requested the uncompressed raw imagery, that's something that could be a single data set could be a dozen terabytes or more. So there needed to be a lot of storage space available. Right, and so on this storage server, it's also where we're running an FTP server, so that, like I said, if you're going to download this stuff from the FTP server, you're getting it directly from the data source. It's not copied to a separate location, so that we don't have a bunch of these data sets being duplicated. And so if I look inside the imagery folder in this FTP server, you can see the folder names are just like what I just looked at in Windows Explorer, and it's the same thing that someone would see if they're looking at it on an FTP client. And so all the data that's available there on that storage server, like I said, is read by the GIS server, and there's really not much to look at, so that's why I only have the Windows programs to show you what's installed on this server. It's just a piece of software called ArcGIS Server. And you can manage that through a web interface. If I can see my tabs here, let's see. To see what's running on this ArcGIS server, see some of the services. So these were all published from ArcMap. They were published a while ago before I started with ArcGIS Pro, and these are the different image mosaics. So when I'm talking about a web service, you could think of a web service as being a little program that's running within a program, if you want to think of it like that. So overall, we have this the software called ArcGIS Server, but it's running all these separate little applications that serve up web services. And so this one in particular is running a web service that provides a 1998 DOQQ imagery. And so ArcGIS server lets you decide things like if you're going to offer it in a WMS web service format, so like an open standard for web maps, and then some technical things like how many instances, or basically like how many cores in your processor do you want ArcGIS server to use for this particular web service. So if it were more popular, you might want to assign it more processing power, and of course things like metadata. All right, so that's ArcGIS server. That's what it, let's see, that's what, when you see this, when you're out searching for GIS data online, and you see this, the really plain looking blue and white pages, this is just an ArcGIS services directory. And so what I just showed you in that management interface, this is the same thing here. This is what the URL that you would copy into QGIS or any other application that you're using that wants to consume the web service. All right, so that ArcGIS server is running on a physical server that's actually in the LSU data center. But part of where ArcGIS is going, or I'm sorry, where Atlas is going, is to ArcGIS Online. So kind of getting away from having so much local computer resources that you know, that break and then have to be replaced every few years and things like that. Because now, you know, so-called cloud services are a lot more affordable than they have been, and they're easier to use. And specifically with ArcGIS Online, they've made a big improvement to where you can control your costs a little bit better, and not basically not use up all of your credits and have to worry about getting billed for huge consumption of resources on ArcGIS Online and things like that. So ArcGIS Online has gotten a lot more feasible for something like Atlas, and it still can't store a ton of data online. It would still be pretty expensive, but it is feasible to and affordable to store some of the base maps in a tiled format. So it's not the raw data, but it's more like a kind of like a preview where a bunch of JPEG images get processed from the source imagery and arranged into a mosaic and then uploaded online to ArcGIS Online. To where you have something like this, where when I view this base map in ArcGIS Online, it's not pulling anything from LSU servers anymore. And if you're an avid user of the base map, you'll see that the color has changed a little bit for this LiDAR base map, just because when I published it to ArcGIS Online, which was just recently, this week actually, the color ramp changed a little bit, but this is all contained within ArcGIS Online. And so I started, I think August was the first time that I moved some of ArcGIS, or moved some of Atlas's base maps from the LSU servers to ArcGIS Online. And it seems to have been working pretty well, and it didn't use up a ton of credits or anything. So I'm going to be moving more and more of the base maps to ArcGIS Online. And I'm calling them base maps. So it's just the tiled versions of the data set. So like I said, so it's not the raw data, it's just these JPEG or PNG images in very small tiles, very small dimensional of squares. that get mosaic together, and what you see is a seamless base map. I'm zooming out there because if you, or zooming and panning it out, because you can kind of see, depending on how fast the internet connection is, you can see how it's individual squares that load in, right? The map doesn't just always appear immediately. Sometimes it's, you can see the individual squares loading in. Those are the tiles that I'm referring to. So just really small images that don't take as much space as the raw data set and get stitched together by the web map. Right, and so putting these web maps on ArcGIS Online, from the user perspective, it doesn't really change much, right? If I go back to the Atlas homepage, if you're going to download LiDAR data from Atlas, you're still going to have the same experience where if you go to the map and download, and you click on a quarter quad, the files you download are still coming from LSU's server. The only difference here is that behind the scenes, this base map is coming from ArcGIS Online instead of a web service hosted at LSU. Now, where a change for the front end, so what the user experience would be coming, is if I start to use something called ArcGIS Hub, which was also known as ArcGIS Open Data. Sorry. Let's see. So this is another site format that also might look familiar because more and more organizations are using this ArcGIS Hub to distribute their GIS data. I mean, if anything, you might recognize some of the generic icons here. Basically, it's kind of like a different front end for ArcGIS Online. So the data sets that I have available so far through these different categories, these are all hosted on ArcGIS Online. Although some of them could more or less just have a web page with metadata on ArcGIS Online, but the actual data points back to your own local ArcGIS server. So if I click on some of these, this interface is one, I know that the city of New Orleans uses this type of interface to distribute some of their data. Baton Rouge, I believe, has something similar too. Right, so this data set is just a vector data set, and it's hosted on ArcGIS Online, but basically you can, in ArcGIS Online, once you have a hub set up, you can share data with a group, and it will just appear on your hub website. So this is that homicides layer. So if I go to share it, to make it go from just being a layer that is published to your ArcGIS Online account to being a layer that's available publicly on your open data website, you just share it with a public group, and specifically a group that I have set up for the open data site. So once it's shared there, then you would be able to go back and to your hub site, and it would be available there. So it's and the descriptions and things like that are all pulled from that original layer that you have published to ArcGIS Online. So it simplifies the the process of maintaining a site like this. And it just makes a lot of sense considering that through education, we get a pretty big discount for ArcGIS Online. So, you know, of course, they provide these incentives. Esri provides these incentives, I think, for education. It's nice, but, you know, they're probably getting us hooked on it, and so that we teach it to the students and they go out into private industry and so on and so forth. But from a practical standpoint, it's pretty hard to resist that offering, because it is such a nice platform that can do so much at a low cost, and it's easy to maintain, especially for something like Atlas, where it isn't like an official government or an official state portal or something where it has a team of people and dedicated funding or anything like that. It's pretty much just me doing this and, you know, the quote unquote free time. And something like ArcGIS Online and ArcGIS Hub is a lot less time consuming than what I even have now, which is a WordPress site, which is open source. And then I'm also using Leaflet, which is again open source. But going back to what I originally said about the first Atlas website being developed by one person from scratch, and then me kind of continuing that, even though the alternatives that I went with were open source and more modern, up to date, and all that kind of stuff with more documentation available. When it comes down to it, it was still something that I had to code myself for a large part of it. And so it's really difficult to get other people to bring in other people to help me work on it if it's like that. Whereas a site like this, based on user accounts and things like that, and of course not involving as much programming or maybe even no programming, it's a lot easier to get graduate students and things like that to help out with this kind of thing. So when you see other GIS portals using something like ArcGIS Online and ArcGIS Hub, there are definite advantages, even though there are also disadvantages, like not being able to make it look exactly how you want it, and, you know, all the customization just isn't there. And so it's a sacrifice in some ways, but overall it has its benefits for maintaining something like Atlas. And like I mentioned, in addition to having data that's actually hosted in ArcGIS Online, you can point it back to your own data sources. Let's see if I can find one. Yeah, actually, I think I don't have it shared out, but I do have one. This Landsat 8 mosaic. So it has this page in ArcGIS Online that makes it searchable and through ArcGIS Online, and you can add it to a hub site and all that. But if you go and look at its web service URL, you can see that it is still hosted at LSU, and so that's because this isn't a tiled cache. This is a web service that actually points to the source imagery. And so one benefit of something like that is that you'd be able to get pixel data. So that would be useful for analysis, and or if in some cases, depending on what the capabilities of the layer are, you might be able to change the coloring. So do a different kind of false color for a satellite image or something like that. So in its current state, Atlas is really a mix of all kinds of different software, different methods, hardware, virtual servers, physical servers, things like that. and basically just doing, trying out different things to still make this data available in different ways, and trying to keep up with the times while also keeping things easily manageable for myself and anybody else who might come along and get involved in this. Yeah, so that's really it. That's a look behind the scenes. If you have any questions or anything like that.
Cool. Thanks, Luke. That's awesome. I had a couple of questions. I was wondering, my first thought was, do you record usage statistics much? Or do you know kind of download numbers or anything like that, just out of curiosity?
You know, not that I have checked, and that's one thing I told myself I should have checked before the presentation, but I had Google Analytics
Mm-hmm.
that I put on in 2016, but I just haven't been keeping up with it. And
yeah, cool.
I mean, it's the web server logs would keep all of that information as well. So basically, I just haven't been checking on it. It's the kind of thing that when it comes time to have to write another grant proposal, I would have to dig into that kind of stuff. But it's not something I've been looking at keeping up with.
Yeah, cool. I was also wondering, if you could go back to the main Atlas homepage, if you could just say like a couple sentences about the other, is it basically these 4 data sets, right?
Oh, if I go to the data sets.
Oh, okay, cool.
Yeah, what the new Atlas is mainly focused on these raster data sets.
Right.
Right. And so all of the old vector data sets, so basically the entirety of Atlas, aside from these raster data sets, totaled like 14 gigabytes. So I put them into a single zip file and called it the Atlas archive. So all those old like former boundaries and things like that, as well as a bunch of different infrastructure data sets, those are all included in the Atlas archives. And a lot of that came from a couple of DVDs that were released in 2006 and I think 2007 that included stuff like school information and the road network for Louisiana and things like that. So those are included in there as well. But on the other Atlas website, which is where it was better than the current website, is that it had a way to browse through and kind of filter through these vector data sets. And I never put the vector data sets on the new Atlas website because it's something that would have either needed to be developed from scratch again, because there's really no way to do that with WordPress, of course, because it's not supposed to do that. And so the idea was always that ArcGIS Online would be involved in some way for the vector data sets. And I wasn't sure how. At one point, I had started putting together a portal site, kind of like ArcGIS Online, that you install on your own servers. But there was always something wrong with it. There was always some kind of catch, and eventually it got to the point where I could see where it was all just going to have to go to ArcGIS Online. And so I think now, if not all of those vector data sets, at least some of the ones that if I can look at some of the old statistics, old download statistics, I can put those up onto ArcGIS Hub, because that seems to be the way, a better way to handle these vector data sets, because it gives you the nice preview of them on the map on the data set page and all that. Yeah. So this Atlas archive actually contains a huge variety of different kind of data sets. just represented on the new atlas by that one title, Atlas Archive, and then everything else that's on the website is these raster data sets.
Mm-hmm. Cool. I guess related to that, I was just wondering, what is the process for new, say some of those more recent aerial imagery, like how do you end up with those data sets, and how does a new data set end up in Atlas?
Yeah. Let's see. So for like one of the more recent ones, this 2017 Richland Parish. So that came about by the assessor's office in Richland Parish just emailing me and asking if they could, if I wanted to host this data set.
Mm-hmm.
And not too many people are coming to Atlas anymore to try to get stuff hosted. Like I said, it's kind of become more of a historical data site. But so I said yes to that, and so but their intention was that it would be hosted as a web service and also be available to download. And they were actually going to use it on their website. So if you were to go to the Richland Parish Assessor's Office website and look at the parcel data that they put online, their base map was coming from the Atlas website until recently, when I moved it onto ArcGIS Online. And so there now, if you go there, it should be pulling from the ArcGIS Online tiled cache,
Mm-hmm.
but it's still available for download, the source data on Atlas individual files. So basically, it was just kind of a very informal thing of the assessor's office in that parish emailing me and asking me if I wanted to put it on Atlas, and some other things like let's see. Yeah, like the newer topo maps. So it was just John Anderson in the map library. Somebody had given it to them or given it to him, and he asked if I wanted to put it on Atlas. So basically, if somebody comes to me with a data set that they want to be publicly available, then I'll put it up.
Cool.
And yeah, and as far as a specific process, so let me take well, going back to the Richland Parish. So they'll give me, like, they might either mail me a USB hard drive with it,
Mm-hmm.
and then I just take those individual imagery files and I'll use ArcGIS Pro to, or now I'll use ArcGIS Pro before ArcMap to make a mosaic data set, right? So I can, just inside of a FileGeo database, I'll create a new mosaic data set and then add all of their individual images to it.
Mm-hmm.
And then when you create a mosaic data set in Pro, then it also creates a vector layer, so the footprints, right? And then the attributes for those footprints, they contain the name of each one of the images. So it's a handy pointer to the actual file. You know, it doesn't have the extension, but assuming that the name that's in this attribute is going to be the same as the actual file, then you have a handy little vector layer that you can put up on your web map, and through a little bit of JavaScript, when somebody clicks on an individual feature, and not just JavaScript, but that's Leaflet doing the heavy lifting there. When someone clicks on one of those individual feature footprints, then you can have it go and download the the file associated with it, so the file that has the same name. So if I scroll in to the downloader here and click on one of the footprints, and zooming in further, you can see the footprints overlap a little bit. So these lines are representing the actual edges of the image file here. So I'll click on it, you can see that it has a little bit of metadata there, the ID from that footprint attribute table. And then you can just kind of programmatically build the URL to download each one of those. So it's just the base directory, and then add .sid onto the end of that ID to be able to download the file.
Nice.
And then those mosaic data sets, you could either publish those as an image service, but for this I just published them as a tiled cache. And like I said, it was published to ArcGIS server, but I recently started moving all that to ArcGIS Online tiled caches.
Yeah. Cool. Great. Well, thanks for presenting me.
Yeah, no problem.